Good morning, students. Welcome back to Physics Marathon part. And this side, Puneet Kathuria, your physics faculty at Aakash Institute. So, warm welcome to all of you again. And today we are here to discuss about most of the questions you people have committed wrong in your AIATS Plus Phase 2. And that is mock test 7 conducted on 2nd of March 2025. So, we will be discussing some of the questions which you people have committed wrong. Most of the students have committed wrong these questions. So, let us build up their concept, let us understand and let us move on with the series. So, today's discussion is all about these topics. So, these topics are from current electricity part, motion in a straight line, kinetic theory of gases, thermodynamics, alternating current and electromagnetic waves. So, these are the topics primarily we will be discussing in this session of your physics marathon. So, shall we start? So, Virender sir, good morning. Virender Kumar ji, good morning. Now, the very first question, a group of 6 identical cells, each of EMF E and internal resistance R, are joined in series to form a loop. The terminal voltage across each cell is. So, before we attempt this question, let's build up some of the basics of this so that you people can actually understand and perform varieties of numericals based on this. So, let us begin with a cell. A cell EMF E, internal resistance R. Now, when you draw current from this, so this is the first stage I am talking about when you are actually drawing current from the cell. So, what you call this condition as your discharging. So, this is I am talking about the discharging condition. So, when you draw current from your cell or from your battery, we call it as a discharging. So, in this situation, there is some potential drop across the cell itself. So, the terminal potential difference across the cell will be given by EMF minus, so we are drawing current I, internal resistance is small r. So, this is the terminal potential difference between these 2 points, that is potential difference is E minus IR. So, this is the first situation we have. Now, second situation we have is for the charging stage. So, when you have the charging stage, so first you understand the charging part. So, when you charge a cell or a battery, it means current is being fed into this. So, in this situation, what is your terminal potential difference? So, that would be E plus IR. And when circuit is open, means you are not drawing any current and you are not feeding any current to your cell or battery. So, in that situation, V is equal to E. It means your terminal potential difference is same as that of EMF of cell. So, these are the 3 prime basic concepts that we have just understood about your cell, or when cell is in discharging stage, charging stage, or when circuit is open. So, this is all about the potential difference. So in this case, you can see V is definitely less than E. This is very important. In this situation, your V is greater than E, and in the third situation, V is equal to E. Janak, good morning. Dashrath, good morning. Kumaran, good morning. So, very good morning to all of you and welcome to this class. So, we have just introduced the basics of this cell and your potential difference. So, any doubt from this part? So, this is one part, this is one concept. Now, we have combination of cells. So, let us suppose we have two cells E1, R1, E2, R2, and you know, in this situation, what is the net EMF when you have these two cells? They are connected in series and they are supporting each other. So, you can see they are supporting each other. So, equivalent EMF or the net EMF would be sum of these two, and internal resistance would be added up like this. So, this is the main concept. Now, this question is revolving around this combination of cells only. So, it says a group of 6 identical cells, each of EMF E and internal resistance, are joined in series to form a loop. So, let's understand, we have a loop. So, we have 6 cells. So, 1, 2, 3, 4, 5, 6. So, all are identical. And you know, they are joined in series to form a loop. So, this is the concept. So, can you see the loop? And 6 cells are, this is how they all are arranged. And if you look at it, they all are arranged like supporting each other. They all are connected in such a fashion that they all are supporting each other. So, what is the net EMF? So, definitely net EMF would be sum of all based on this concept. Look at this. When these two cells were taken into consideration, these two cells were supporting each other. So, they all, these all are also connected in the same fashion. They all are in series. So, net EMF would definitely be sum of all the individuals, and this is the net EMF 6E, because 6 cells are there. Now, their internal resistances are also like this. So, net resistance is 6R, and that gives you current as, what is this current as now? E by R. I hope we all have, Manalika, good morning. So, I hope we all have understood how we got the value of this current which is flowing through this circuit. Got it? Any doubt from this part? Shall we? Now, question is, what your question says? The terminal voltage across each cell. So, we need to find out the terminal voltage. So, let's say this is the cell we are selecting, and we have to find out the terminal voltage about this part. Now, if you look at the circuit very carefully, what you observe is this cell is in a charging stage, or is the cell in a discharging state? Yes, anyone? This is discharging stage. So we have just understood for the discharging stage, the terminal potential difference or voltage is given by E minus IR. So because we are finding it out across this battery, so what is this EMF? EMF is E minus what is the current? Current is same, being a loop, and we have already obtained the value of current as E by R into small r. So this r goes with this, E minus E becomes 0. So this is the terminal potential difference or voltage across any of the cell. Any doubt? Neeraj Sharma, he has given 0 as answer, and that is perfectly fine. Well done, Neeraj. Ha ha ha, just read the comment. Okay, fine. So we got the answer as 0. Yes. Anything else if you would like to ask from this part, or shall we move? Shall we? Okay, fine. I am moving to the next question. Now next question is also quite interesting, and that is from a different area. If a coil of resistance 10 ohm, the variation of current with time has been shown. So this is the graph, or this is the graph between current and time. The magnitude of change in magnetic flux is. So this is quite interesting. The magnitude of change in flux, we have to find it out. So what is the magnitude of change in flux? This is your question. So what is given to you is current versus time graph. So first of all, I would like to give you the main formula, how you can correlate change of magnetic flux with the charge. Basically, this is a concept of electromagnetic induction, where you have the induced charge. As per your Faraday's law, the magnitude of induced EMF is given to you as, what is this? This is change of flux with respect to time. This is the main concept. And when you divide both sides by R, that is the resistance, you will have induced current in the circuit. And this induced current is induced charge per unit time. So when you find out induced charge, that gives you magnitude of change in flux per unit resistance of the coil. So this is the main expression. So once you know the formula, then I think this part we can easily obtain it from this one. So we know current is dq by dt, and I into dt will give me the total charge, and this is the charge induced, and this is basically your area of graph, and that gives me the induced charge that is flowing through the circuit. So these are the two prime concepts we have just understood. So if you need to know the induced charge, I think I've already given you, stated you the main concept. How you will find it out? Just by finding the area of this triangle. So this is area of triangle is half into base. So base is 0.1 seconds into height, and this height is 4 ampere. and this is the answer for the induced charge. So when you multiply induced charge, that means with resistance. So resistance is given to you as 10 ohm, and that gives me the magnitude of change in flux. So how you will get it? So this gives you 2, and the unit for this is definitely Weber. So this is the complete concept for this numerical. So we have understood it very well. Any doubt or anything you would like to ask from this particular section? So Amit Kumar and Devshri, good. So I'm moving forward, moving ahead. Any doubt? Nothing? Fine. So I am moving to the new concept. A capacitor of capacitance 10 microfarad is connected to an AC source of 220 volt 10 by 2 pi. The capacitive reactance is. So first we need to understand this is what is given to you as. So source, when you say it is source, so basically this is your supply, and which is given to you as 220 volts, and this is 10 by 2 pi. This is basically the frequency, and it has to be in hertz. So this is the source. Capacitive reactance. So first of all, what do you mean by capacitive reactance? Any idea? Capacitive reactance is understood or interpreted as like this is the resistance offered by your capacitor to AC supply or AC circuit. And when you define it as resistance, so unit wise it's defined as, when it is understood as resistance, so this is also defined in terms of ohms. And capacitive reactance is given to you as XC. So XC is the notation to understand or to define capacitive reactance, and this is given or understood as 1 by omega C, and this omega is 2 pi into frequency of the circuit supply, and this is C. So as you see, this capacitive reactance is inversely proportional to frequency, and for DC your frequency is 0, so capacitive reactance would be 1 by 0, that means infinity. So it means capacitor will offer a very large value of resistance to your DC supply. So that is why usually in steady state capacitor blocks DC. So this is again very important. And for AC supply, where you have some frequency, this is how it is, because this we have already understood it as this Xc is inversely proportional to frequency. So with the increase in frequency, So it keeps on decreasing. So this is again one of the important concepts from this section. So but the question or the numerical is quite easy and quite simple. We are supposed to find out capacitive reactance. So this is what we have to find it out. So if I say capacitive reactance as 1 by 2 pi nu into C, so just put the values there, and I think frequency was 10 by 2 pi and capacitance was 10 microfarad. So this is 10 by 2 pi and this is 10 microfarad. So this micro means 10 to the power minus 6 farad. So this is how, and the numerical value are quite easy and manageable. So that gives me, this is 10 to the power 2 and minus 6, so that gives me 10 to the power 4. So this is the value for the capacitive reactance we have. If I ask you the unit wise, units, this is ohms. So first option is the correct answer for this. Any doubt? Any doubt? Or so I am just suggesting you one thing again, which I have been suggesting you in my previous sessions also. So what is important for you is you maintain a list of all the formulas, at least for the numerical part. If you know the formula, then you can just by putting the values, doing your simple mathematical calculations, you can have the answers for all these questions. So any doubt from this part? Anything else? Shall we move? Fine. Now the temperature of source and sink of a Carnot engine is given to you as 227 degrees C and 127 degrees C respectively. Its efficiency will be. So we have a Carnot engine. So Carnot engine, let's understand bit of the Carnot engine. So basically this is your ideal heat engine, and this is reversible. And when you say ideal, it means no losses. So what do you mean by Carnot heat engine? So Carnot heat engine is basically your ideal heat engine, and this is reversible in nature, and this is involving no losses. So we are assuming there are no losses involved in it. So this is the one. And when you have heat engine, so what are the components of your heat engine? So you have a source, that is usually a hot body. So you draw heat from the hot body because that is like a source. So you have a working substance which is usually a gas. So it absorbs some amount of heat, let's suppose Q1. So it draws some heat, rejects some to your sink. Sink is your relatively a cold body, and does work also, and which is equal to, as per your values. So this is Q1 minus Q2, this is the amount of work done. So this Carnot heat engine, so we have added few more important terminologies. Carnot heat engine, what is Carnot heat engine? So it's an ideal heat engine, one thing. Reversible in nature, then there are no losses assumed in this. That is why we call it as a ideal heat engine. Then the components, the main components, so source, working substance and sink, these are the three main components. So it draws heat from the source, throws some of its heat absorbed, labeled as Q2, to your sink, which is relatively a colder body. Then the amount of work done is given by Q1 minus Q2. So these are the basic terms. Now we have another term, that is efficiency. So efficiency is basically your output, that is your work done by your input heat absorbed, and your work done is Q1 minus Q2 by input is Q1. So shall I call it as 1 minus Q2 by Q1, which can also be written in terms of its temperature as 1 minus T2 by T1. So T1, we are assuming the temperature of your source, and T2 is for the temperature of your cold body or your hot body, which is your surrounding. So this cold body is your basically the surrounding part. So we got the expression for the efficiency in terms of the temperature of the hot body, that is source and sink. So in terms of temperatures of the hot body and the temperature of the sink, we got the expression for the efficiency. So now the question is, once you know the formula, now can we find it out? Yes. Important temperatures, this is higher temperature, this is source, so T1, this is your relatively sink, this is T2. Important point again, this temperature has to be in Kelvin, though it is given to you in degree centigrade, but it has to be in Kelvin, and we know how to find out the temperature in the Kelvin. So efficiency is 1 minus T2 by T1. So this is 1 minus, what is T2? T2 was given to you as 127 and T1 was 227. So this is 227, and when you add 273 to it, so this means what? 400 Kelvin, and this is 500 Kelvin. So these are the temperatures. So 1 minus T2 and this T1, and in terms of percentage, you need to multiply this number with 100, and that gives me 20% as the efficiency for this ideal Carnot heat engine. So I hope we have understood all the basic processes involved in understanding of this Carnot heat engine and its efficiency. Any doubt from this part? Anything? So let's check the answer, and we got the expression, or we got the efficiency as 20% only. So I hope this is clear to everyone. Or if you have any doubt, if you would like to ask me anything regarding this concept, you can. Kumaran has given the answer, yes sir, I understood this problem is also good. Good, great Kumaran. Surya, guys, Carnot cycle in NEET 2025. This is important, and once we have this, you know, whatever questions have been asked in your mock test, this AIATS plus 7, we are discussing, I'm like all these questions which most of you have committed wrong. So we are focused for discussion of all these questions only. So my part is related to all these questions which have been selected from the particular 6 areas which we highlighted or discussed in the very first slide of this today's lecture. So I think we should move on. Yes, next is again a very interesting situation from your motion in a straight line, and this is quite interesting. A stone thrown vertically upwards from a bridge with an initial velocity of 4.9 meter per second. It strikes the water after 2 seconds. The height of the bridge above water is. So this is your bridge and this is your water level and this is the height. So here you have a bridge at a particular height. Now you throw, when you say thrown upward from a bridge with an initial velocity of, so it is thrown upward with an initial velocity of 4.9 meter per second. It strikes the water, after 2 seconds. So this is the complete situation. A stone thrown vertically upwards from a bridge with an initial velocity of 4.9 meter per second. It strikes the water after 2 seconds. Take G as 9.8. So specifically mentioned the value of G. So don't take G as 10 because this is specifically mentioned to you as 9.8 meter per second square, and I think there must be some relation when you attempt or when you do the calculation, because 4.9 is there, so that is a hint. Now for this situation, we'll go with your displacement equation. So this is the point from where you have thrown the stone initially, and this is the point where stone is hitting finally the surface, that is strikes the water surface. So water is there below this. So the displacement. So what is the net displacement? If you can see, this is clearly given to you as H. And if you look at the sign convention, this is in downward. So this is minus H. So this H is equal to UT plus half GT square. This is the displacement equation. Now, as you have given downward direction to your displacement, so what is the initial U you have? So that is directed upward. So it's clearly hinted to you as, this numerical value is given to you as 4.9 into T. So what is the value of T? T is given to you as 2. What is this G? This is also downward. So if I put downward as negative, so minus this one. G is 9.8, T is 2, so 2 square becomes 4. So when you solve it, you'll get value as 9.8 only, and that too is downward. So I think we have understood the situation. Any doubt from this part? Anything you would like to ask? Shall we move? Any doubt? So let's move to the next problem. Next problem is something which is quite interesting, and this is like you have to sort of memorize this concept. How? I'll help you. So it says lambda violet, lambda x and lambda m represents wavelength for visible light, X-rays, microwaves respectively. Then we have to arrange it in decreasing order of wavelength. You know, whenever you have questions of all these, so sometimes it becomes really difficult. So most of the doubts we receive, or I personally receive it from the student side, is they usually ask, so it is very difficult to memorize their wavelengths, it is very difficult to memorize their values or their order whenever you have questions based on the wavelength or maybe the frequency. So today I would like to give you the easiest way, and easiest way comes from your electromagnetic spectrum. So spectrum, basically it's a bouquet, or it's an arrangement of all the possible color, wavelengths, frequencies, whatever you can call it as, in definite pattern of frequency or wavelength. So this is electromagnetic spectrum, and today I'll give you an idea how you can memorize these values approximately to answer such varieties of questions. So it all begins with your electromagnetic spectrum, and we all can understand the visible range, which I should write down it as Webgure. So this is your visible range. So you can always make your visible range as your reference, and we know for this violet and for this red, can you see? Because we have used these two wavelengths in varieties of numericals. 400 nanometer or maybe 4000 angstrom. This is 700 nanometer or 7000 angstrom. So these are the two reference values we have. Once you have this reference value, then how you can move on? Red. So after this you have infrared. I'm giving you an easy way to memorize. So what is after red? That is infrared, and on this side you have ultraviolet. You got it? So next to red in your spectrum, this is your infrared, and before this we have a ultraviolet. Then we have microwaves, and on this side we have X-rays, and then we have gamma rays. So now you can see I have given you way to memorize all the possible the broad wavelengths or broad category of all these part of your electromagnetic spectrum. What you have observed in your visible one is when you are moving from violet to red side, it means you are moving from this side. So your wavelength definitely increases, and on this side your wavelength is decreasing. One thing, we know speed of electromagnetic wave, that is given to you as c, which we can write it down as lambda into frequency. So if lambda increases, frequency decreases, and this is how we got a, the broad spectrum for this. So this is the way, easiest way to memorize such kind of problems. Now we have to pick. As you can see, wavelength increases. So wavelength of microwave is definitely more than infrared, that is more than your red, then finally violet, then more than your this one, X-rays and gamma rays. So this is the broad classification. Today I have helped you to memorize and to answer such kind of problems. Now the problem is we have to rearrange. So if I label this as lambda for microwaves as this one, and no doubt if you observe this, lambda is maximum for microwaves, no doubt. So lambda m will have the maximum wavelength for this one. Then next one is your X-rays. So X-rays somewhere here, so it has a small wavelength. Then we have micro and then visible. Visible is this part. So the maximum wavelength is for microwaves, then for the visible part, and the least is for the X-rays. And question is decreasing order. So when they ask you the decreasing order, it means we have to put the wavelength which has the maximum value. So microwave is maximum, so this is okay. But do we have more than X-rays, then visible one? No, it has to be the other way. This is also not correct. So yes, lambda of microwave is more than the visible part, then X-rays. So this is the correct option we have, and for the frequency it is the other way. So I hope we have not only just memorized this concept, we have understood it clearly, and we got the trick how to answer such kind of questions broadly. So this will help you to answer at least in terms of wavelength and frequency, any order, maybe increasing order or maybe decreasing order. Any doubt from this part? Any doubt? So we got the option 3. Shall we move? Okay, I am moving to the next problem. The next is the ratio of Vrms, Vmp, that is most probable speed, and V average have their usual meanings. So we have to find out their ratios. So Vrms, so basically RMS stands for root mean square velocity. Gas consists of molecules. We are very clear. And they have no interactive forces, so there is no concept of potential energy, but they all are moving randomly within that container. Now, so it means they all have different velocities possible in all the 3 possible directions. So this is one terminology, how we define their, this motion, how we understand their motion. So Vrms, root mean square. So this is basically, we can define it as So we'll take square of all, and then let's suppose you have n number of molecules you are talking about. So this is square. So we are doing it. Then we'll take the mean and finally the root. And you know, numerically we have just understood it for the different one, and using this concept we can find out this formula as, based on the kinetic theory of gases, 3 RT by m, where T is the absolute temperature, that is in Kelvin, m is the molar mass, and R is your as usual the universal gas constant. So this is the numerical formula for the root mean square velocity. Then we have most probable speed. So this is basically understood as speed possessed by maximum number or fraction of molecules in the gas. And you know, this most probable speed is given to you as 2 RT by m. This is also there. Then average speed. So how you define the average? Simple is you simply put all the values, because we have already assumed the gas molecules, they are in random motion, and this is how we usually take the average, and this is given to you as 8 RT by pi m under the root. You got it? So we have to find out just the ratio. So this RT by m is a common part, so this gives me root 3 is there, root 2 is there, and 8 by pi. So we are getting a clear answer. So root 3 is for RMS, root 2 for most probable speed, and we have average is 8 by pi. So this is the correct option we have. Any doubt from this part? Now important point, when you define the, I'm just adding you one more area or concept that you must retain or you must understand. When you define the average kinetic energy for a gaseous system, so out of these three, which velocity will be used to define the kinetic energy? Is this most probable speed, average speed, or the RMS speed? Yes. So this is basically the RMS speed, that is highest among all the three. This is basically used to define the kinetic energy of the gaseous system we have. So this is from this part. Any doubt? Any doubt if you would like to ask? So shall we move? No more doubts? Okay. Yes. The relation between position, that is given to you in millimeters, or that is in meters, of a particle and time t is in seconds, is given to us as S is equal to, so this position is S is equal to 2t cube plus 3t square plus 2t plus 8. So this is the situation. So this is how position of the particle varies with respect to time as per the given relation. Now we have to find out then time, okay, at which acceleration of the particle is 0. So this is the situation. So situation is, you have a position time equation given to you. Then they are saying at what time? So they are asking you the time part, but when the acceleration is 0. Now, if I help you to understand this, so position is a function of time. So can you define ds by dt as the instantaneous velocity of the particle? This we understand it. So we simply need to differentiate it. So we'll keep 2 as constant. The derivative or the differentiation of t cube will give you 3t square plus 3 is constant. The derivative of t square becomes 2t. 2 constant. Derivative of t will give you 1, and for the constant part it's 0. So we got the expression for the instantaneous velocity we have. I hope this much we all understand it. Now velocity is again a function of time. So when you differentiate, what you'll end up with? You'll end up with acceleration. Now this acceleration, so this becomes 6, derivative or differentiation of t square will give you 2t. So this 6 derivative of t will give you 1, and this, the next one is 0 definitely. So this is how we got the expression for the acceleration, and as per your question, acceleration of the particle is 0, and when you put this as equal to 0, so that gives you time in negative value, which is not possible at all. Not possible, you can see. So it means whatever condition they are asking, is it possible as per the given situation, as per the given relation? Answer is no. So it means, do we have the time 0.5, 2 second, 1 second? No. We are left with only one option. That means acceleration can never be 0 in this case, because that way you will have a negative value of time, which is practically not possible. So it means acceleration will never be 0 for this given situation. Had it been like this, if I say your acceleration was 12t, instead of plus over here, if I go for the negative value at this position, minus 6, then definitely this primarily gives you the value of t as 0.5 second. That way this situation would have been possible if you have a negative sign there, but this is not the case. So we simply say that situation is not possible, so acceleration cannot be 0 in the given situation. I hope we have understood this. Shall we move? Okay. Move to the next part. For the cyclic process, the work done during process BA. So we have to find out the process, the work done from B to A. And you know, this is a PV curve. So work done is basically given to you as area under this curve, and which is equal to area of trapezium, and area of trapezium is half into sum of parallel sides into height of the trapezium. I think this we all are very much clear. So what is the sum of parallel sides? So can you see this as 1 into this, and can you see the other side as 3 into this? So when you sum, so that makes it multiply by height. Height is 3 minus 1 as 2. This goes with this, and this is 4 into 100 as 400 joules only. So this is 400 joules. Very simple question, but we need to understand this is a positive work done because volume is increasing, and this is how we got the expression. Moving to the next question, the degree of freedom for an ideal gas is F. Then the value of molar specific heat at constant pressure. This we have to find it out. Do we have an idea about molar specific heat at constant pressure minus molar specific heat at constant volume is given to you as R. And we know CV is given to you as degree of freedom F into R by 2. And when you put the value of CV in the above expression, so that gives me R plus FR by 2. So when you take R common, so it gives you 1 plus F by 2 as the expression for the CP. And this was the simple question. So do we have option like this? No. Second is the clear winner. So we got the expression for the molar specific heat at constant pressure. So this is all from my side for today's session of physics marathon part. So we did discuss about the AIATS plus phase 2 mock test 7 conducted on 2nd of March. So any doubt you can continue to ask, or you can give your doubts. So for then I think sufficient from my side. So this side Puneet Kathuria, your Aakash faculty. So goodbye for now and get ready for the next session. So Arun sir will continue with the next session. So please stay focused for the next part. Thank you. Thank you. चलो मिलते हैं।